I guess I just want to describe my own way of understanding the weirdness of quantum mechanics, of quantum non-locality, in a way that's a little different than Bell's inequalities. So there is another theorist, Lucien Hardy, and he came up with another theoretical proposal that enables you to see the inconsistency of quantum mechanics with intuition in a way that didn't require any inequalities. And he and I were actually at a philosophy conference together 30 years ago, something like that. And we were trying to come up with an example that we could explain to the philosophers and to our families, for example, that wouldn't require math or wouldn't require knowing any quantum mechanics. And so we came up with this analogy. So we imagine that we have a kitchen, a quantum kitchen, and on that kitchen we have conveyor belts going out to the left and to the right. And on those conveyor belts we have pairs of ovens that come out, a pair going off to the left, a pair going off to the right. And those ovens have baked goods from the kitchen. So if we open the oven at the end, we find out that it has a cake inside. It's had a cake inside the whole time, presumably, but anyway, it has a cake inside, and we can test is that a good cake, good tasting cake or a bad tasting cake? So we can see, does it taste good or does it taste bad? Okay, the other type of measurement that we can do is we don't wait until the end to open the oven. We instead open the oven in the middle, and we ask, in that middle case, when we open the oven door, has the batter of the cake risen by that middle stage, or has it not risen? Obviously it's rising somewhere along because when it starts out, it's completely uncooked. It's cooking, the cake is cooking as the ovens are going on along the conveyor belts. So we just ask, by that middle stage, has the batter risen? Now, this is, I don't know, some sort of a souffle or something like that. So when you reclose the door, the whole thing collapses and it just tastes terrible. So you have to choose to make one of those types of measurements. You can either measure in the middle to see has the cake batter risen, or you can do the taste test at the end, but you can't do both. You have to choose to do one or the other. Okay, so we've got the two players. The person on the left, let's call her Lucy, and the person on the right, we'll call him Ricardo for R. And there's these pairs of ovens that go out, and Lucy is going to randomly decide for each oven whether she does the taste test at the end or whether she does the batter test at the middle. And same thing, Ricardo is going to randomly decide for that particular oven whether to wait till the end or to measure in the middle. And they're just going to write down the results in their notebooks. So it's completely independent of each other, which measurement they take. They'll write down the results, and then after they have a whole bunch of these ovens, 1,000 ovens that have gone by, then they'll come together and they'll just compare what measurements they took and what the results were. So I'm just going to tell you what the answers were. So in the cases where they both measured in the middle, when they both look to see have the cake batter risen by that middle stage or not, they find that something like 9% of the time, both the cakes had risen early. It might be the case that neither cake rose early, so that only one of the cakes rose early, but 9% of the time they find that both rise early. Okay, so that's just first fact. If we look at the cases where Lucy measured in the middle and Ricardo did the taste test, we now see kind of an interesting correlation. We see that whenever her cake rose in the middle, whenever she measured that the batter had risen in the middle, we find that in those cases, if her cake rose early, his cake always tasted good. And also vice versa, if he did the batter rising measurement and she did the taste test, whenever his cake was observed to rise early, then her cake always tasted good, 100% of the time. Okay, so that leads us, there has to be some correlation in the history of the cakes. That's the only way you can possibly explain that definite correlation. So they came from the same batter, they're made by the same chef inside the kitchen. That's the only way to explain that. Okay, so now we have three facts. One fact is that 9% of the time both cakes rise early. A second fact is that whenever one cake rose early on the left, the cake on the right tasted good. And the third fact is whenever the cake on the right rose early, the cake on the left tasted good. Okay, so those are the three facts that we're starting with. And now on the basis of those three facts, we just have to ask, well, what should we predict if we look at the cases where both people did the taste test? Because we've looked at the other cases where both did the batter test and where one did the batter test and one did the cake test. So there's only one more possibility is they both did the taste test. So if we look at the cases where they both did the taste test, we can ask, well, what should we expect based on those other three facts? So I maintain that both cakes rose early 9% of the time, and whenever one rises early, the other one tastes good. It must be the case that at least 9% of the time, since 9% of the time both rose early, it must be the case that at least 9% of the time both the cakes will be found to taste good. And I kind of hope that's really intuitive to you, and I encourage you to think about it so that it really is intuitive that it happens, that's how it happens. So that's the expectation based on our classical understanding of things. The problem is that I can make a pair of quantum mechanically entangled cakes, or equivalent system with photons, for example, such that it never occurs that both cakes taste good. They can both taste bad. One can taste bad and one can taste good, or vice versa, but you just never get them both tasting good. That just is not one of the possibilities. And yet the other three facts that I said are still true. And so that is just amazing that that can be the case. And what happened in our intuition when we gave this, what I said had to be the case, that at least 9% of the time both of them have to taste good, we've implicitly assumed that when you make a measurement on one cake, it doesn't influence what the result of the other cake, of the measurement on the other cake will be. And that is just not true. In quantum mechanics, when you make a measurement here, it can influence what the result is on the other cake.